Started it, but and maybe apologies to everybody who's online. I've already started this lecture, so perhaps I'm going to be briefly sort of reintroducing the plan for the lecture for those of you who are online now, and then I'm going to continue with what I have been just describing to everybody in the room. So this is a talk which tries to answer the big question. Can AI hear everyone? And it's part of the critical AI lecture series that Brookback Institute for Data Analytics has prepared for us this autumn. And obviously, we want to go with full screen. And in order to answer this huge question, I've just told the audience that I'm going to be dividing the talk into three sections. Where first I'm going to be focusing on the design of these technologies, and I'm going to be offering some perspectives from linguistics to understand how voice-enabling technologies work. And here I'm going to be focusing on automatic speech recognition, and then that will lead me to to the second sub-questions in the talk, which will be reviewing evidence of performance of these tools, and therefore I will be thinking with you about the factors that we may wish to consider if we want to understand when these tools are underperforming and when they're performing well. And this will lead me to this final question, which is who benefits most from these tools and who might be left behind. So the reason why I'm interested in these topics has to do with my research interests and with the fact that I am coming from linguistics, and I have been very much interested in questions that have to do with people's speaking styles and speech. So a lot of my work is in sociophonetics and sociolinguistics, and I'm what it means in practical terms is that I spend a lot of time working with situated audio and audiovisual recordings to understand how people develop their speaking styles. And I'm particularly interested in the contexts that are often described as the messiest types of linguistic data. So I'm working with multilingual speech, and in these contexts, I'm very much interested in understanding how people, when people adhere to linguistic norms and when linguistic innovation can occur and what can trigger change in terms of especially sound systems of languages. So here, that means that I do a lot of linguistic annotation myself and transcription, and I'm very much interested in politics of transcription and in understanding how these minute details of language, human language work, in order to understand how human language sort of sits in relation to the use of objects, technologies, aspects of physical space, but also aspects of sociocultural space. So I'm very much interested in the question of variation in language, and which means in practical terms, again, that sometimes I work with very minute details of human speech, such as changing intonation patterns, so the changing melody of your speech, or aspects of consonant production and stuff like that, so different sounds that you may be producing. And that means that I have worked a lot with phonetic software, and I've developed this interest in ASR, so automatic speech recognition, and its impact on society. So this is where my sort of background fits into this larger sort of context of this talk, and hopefully my skills will be useful for us to understand who may be heard when these voice-enabling technologies are introduced in wider society and who might be still left behind. So obviously the talk will aim to sort of draw your attention to assumptions about both linguistic systems and speakers of languages that are represented in the AI tools that we build, and the importance of thinking of those in order to perhaps make these tools even more inclusive. So obviously I'm operating at this stage of current sort of affairs in voice-enabling technologies, where probably many of us have noticed huge advances in how these technologies work and what they're able to do. And obviously, many of you might have incorporated digital assistants into your daily communicative routines, and you may be talking to Siri or Alexa, you may be using captioning systems when you're on Instagram or when you're on YouTube, and you may be sort of relying on these technologies in new ways. And maybe you have noticed that this is pretty sort of a recent sort of push towards these technologies. And obviously, you might have also noticed that these advances in voice-enabling technologies have often been linked to advances in deep learning and machine learning, obviously also to inclusion of large data sets and more recently, more diverse data sets as well. Obviously, these advances are very much linked to advances in natural language processing, as Alex hinted at 2 weeks ago when he was discussing large language models. And obviously, this is the subset of AI that aims to understand context, language structure, and meaning, and combines the power of computational linguistics with those machine learning algorithms and deep learning techniques, and works on those word embeddings that Alex showed you 2 weeks ago in order to recognize patterns in human language data and convert it into the format that machines can understand. And obviously, large language models come from these advances in natural language processing and enable us to sort of see that the inclusion of these enormous amounts of human language data have sort of produced tools that are quite impressive in how they can process and generate human language more broadly. And as Alex also pointed out, these tools acquire their linguistic competence from surface statistics of their training data. So here, obviously, in order to understand how they work, it is useful to know a lot about intense computational statistics. But I'm going to be also arguing that it's quite useful to know a lot about linguistics and linguistic analysis. Obviously, given my background, I have to note that in any text processing pipeline or human language, spoken language processing pipeline, what needs to happen at the very beginning is that linguistic forms need to be identified. So here, linguistic identification and all the sort of things that come with it, as parsing, stemming, and all that will often be used in AI technologies, apart from obviously voice enabling technologies, where these linguistic tasks will be often like subtasks for larger tasks of these technologies. I'm focusing on voice enabling technologies tonight, and hopefully that enables me to show that some understanding of speech production and perception is quite helpful to understand how automatic speech recognition, for instance, works. So let's focus on automatic speech recognition, and which sits at the core of those voice enabling technologies that you're using and that you see being increasingly incorporated also, not only, as I hinted at before, in your own communicative routines, but also obviously in various social domains in wider society, where we see people interacting with voice AIs in new ways. It's often sort of argued that these technologies can be useful to enhance human experience. So, for instance, studies of deaf communities have shown us that incorporation of technologies of language processing technologies more broadly, might be useful for extending the sociolinguistic capabilities of action of some speakers and language users. And we also know that it might be handy if you're, for instance, second language speaker, and having a transcript, for instance, thanks to automatic speech recognition, can also be beneficial. So we're seeing various people sort of exploring potential of voice-enabling technologies, and at the core of these technologies sits obviously automatic speech recognition. And this is not a new task for computer science, because obviously this task to transcribe the spoken language into writing has been with us from the beginning of computer science, if we think about it. So the very first attempts to successfully transcribe spoken language go back to the 1950s, when the Audrey system was introduced, and shoebox, and these were simple digitizers that were able to perform this task. So they are not similar to many of the applications that are used today. And as you will see, the way the contemporary applications work is much more sophisticated. But the task remains to transcribe spoken language into writing, and it could be reformulated as mapping a waveform to the appropriate string of words. So here it becomes quite important to think, okay, so how do these ASR tools translate this sort of map this waveform onto a string of words? And probably here we immediately see that it's of benefit to think how humans produce speech, because these tools will be obviously working with human language data. And here what becomes handy is the knowledge from linguistics, one of the core subfields of linguistics, phonetics. It gives you the knowledge to sort of understand production, transmission, and perception of speech, and actually immediately draws our attention to where the sound wave is coming from. And obviously here it draws our attention to the human body and the importance of the body for production of sounds, obviously. And when I'm producing sounds tonight, obviously, well, many things are happening as you're trying to decipher what I'm talking to you about. But what is happening on my end is very much an embodied experience when air molecules in my body are moving from my lungs upwards, and as they do so, sound is generated, and the sound is generated in my larynx in my case. But if we had a laryngograph and we wanted to compare the sound wave at my larynx with the one that is released from my body, we would see that the shape of the sound wave would be very much more complex in the latter case. And that obviously has to do with further actions in my body and with actions of articulators in my body, the active articulators such as the tongue and the movements in my mouth and in other parts of the vocal tract, with the vocal tract sort of acting as this filter on the sound wave that enables me to produce different tubes with different, which allow certain resonances to be picked up and some to be damped, and then further transform the sound wave. And then as I release the sound wave to you, obviously we're dealing with a pretty complex series of transformations to the airflow, which could be seen as these air pressure variations that are formed at those different points in my vocal tract. But obviously, you perceive speech that I'm trying to produce. Hopefully, you see it more as a uniform activity. And what you're doing is actually key for understanding what ASR is doing as well, because obviously you're tuning into these sound differences which signal different phonemes and which are important for differentiating words. And obviously, you're doing much more from linguistic perspective. I would argue that you're also simultaneously sort of drawing on your knowledge of morphosyntax, pragmatics, semantics, as well as sociocultural norms and practices that are specific to a particular time and space in which we're conversing. But obviously for ASR, this very first step of phone identification is very important to understand what ASR is doing. And obviously, ASR won't be necessarily doing it exactly as you are doing it, because it has to first sort of transform the analog representation of the waveform into a format that it can operate with. And obviously, it then will be trying to, so first it has to, the signal has to be digitized, and the waveform has to be sort of then transformed into a sequence of acoustic feature vectors. And these acoustic feature vectors are based on the information that ASR tools get from the sound wave. So many, so sophisticated speech analysis is happening in those tools, where they're employing various detection algorithms to extract relevant information that enables the tools to recognize speech from non-speech, and then different classes of speech sounds that I'm producing, or a speaker whose sample is sort of handled by ASR. So obviously here the relevant information from the sound wave will be important, and will be sort of very much, so that the ASR tools will be very much interested in short time features of speech, that correspond to the vocal tract and the spectral envelope. They will be very much interested in identifying how much energy the signal contains. And here they will be using fast Fourier transform algorithm and other types of algorithms to sort of work with identification of those phones. And once the phones are identified, then we have one step of the process sort of out of the way, which is that these acoustic feature vectors are identified. And obviously, for ASR, that's not enough, because then the features have to be mapped onto these likely sort of letters or stretches of words that may correspond to the speech sample that the tool is handling. And the traditional models obviously have relied more on hidden Markov models, and they had they involved the work of experts, for instance, from phonetics, and they very much were interested in working with force-aligned data, with having language, acoustic, and lexicon models to sort of identify these letters that could correspond to acoustic feature vectors. Today, in most applications, we see this push towards end-to-end architectures, which would be most often recurrent neural networks or transformers. And these perform a number of nonlinear operations that then allow to match sort of the acoustic feature vectors onto the probabilities for text that correspond with speech. So obviously, in the end result that we're getting in ASR is a transcript whose accuracy needs to be evaluated, and therefore you will also see many using various metrics to assess the performance of those systems. No metric will be ideal, so obviously there will be quite a few being used. One of them will be the word error rate, which will be taking into account the number of insertions, substitutions, deletions, and divided by the total words in the correct transcript. Other metrics could involve phoneme error rate or character error rate, and they sort of give us an idea of how well the tool sort of performed on different speech samples. And this has enabled the AI developers and researchers on ASR to establish that, yes, for many environments, especially in the English-speaking world, these tools are performing more and more accurately. And we have evidence that this is indeed the case. But there are still some situations, as you might have noticed in your everyday life, when the tools may be still underperforming. So I'm going to be now moving to the second part of this lecture, and I'm going to be trying to begin this exploration of the factors that we may wish to consider to understand what may be going on when the tools are underperforming, with a quote. And this quote is coming from one of the foundational texts in computational linguistics, so Jurafsky and Martin's book from their edition of Speech and Language Processing 2024, where they give a quote that is very much resonant with famous quotes all over linguistics, which immediately reminds us of some important factors that we need to think of. So the quote goes, "Words don't appear out of nowhere. Any particular piece of text that we study is produced by one or more specific speakers or writers in a specific dialect of a specific language at a specific time in a specific place for a specific function." And with this quote, I'm going to start exploring what we know about the factors that have been observed to be affecting ASR and and voice-enabling technologies more broadly. So obviously, many of you may have some observations as to what happens when, for instance, Siri is underperforming when you're interacting with her. And it may be that you've noticed that it has to do with the vocabulary size of the utterance that you're producing. I'm sorry. And this is indeed the case. So research shows that the longer the actions that ASR is dealing with, it may still sort of influence the performance of the systems, and it may produce less accurate transcripts, for instance. If you immediately think about acoustics of the space you're in, that's definitely still important. And obviously we know that if you're in noisy environments, we do have some filters, but it still is still cause more problems for ASR than if you're in quiet environments, for instance. Obviously, then the devices themselves will be important, and so on. But what also probably you have noticed is that there is something with the speech event itself sometimes. So perhaps maybe if you are like me interested in these things and you have started exploring what sort of factors may influence the performance of ASR, you might have played with different speaking styles, for instance. And if you ask ASR to handle read speech as opposed to human-to-human interactions, you might have noticed that it performs better on read speech. And this is also what research is showing us, that there is something with human-to-human conversations that still needs to be explored, and there is more research on that as well. So that brings me to this point where I want to sort of explore with you a little bit more what we know about how humans interact with machines, and how that affects both their speech perception and speaking styles and speech adjustments that we make to converse with these technologies. And here, as I said before, I'm going to be drawing on research from human-machine interaction studies, but also from phonetics, phonology, studies of social interaction, and sociolinguistics. And I'm going to argue that we could sort of start exploring what may be going on if we predict that people may be prone to use the same social structured representations and patterns of behavior from human-to-human interactions to interactions with technology when machines use spoken language. And I'm going to be trying to put these two bodies of research in dialogue to show you why certain things may be happening in interactions with machines. So obviously, one of the important aspects to think about is speech perception. So what do we know about humans perceiving speech produced by machines, and how does that perhaps differ from what we know about how humans perceive speech from other humans? So when we start with the latter, when we start with what humans do when they perceive, what type of speech humans perceive better when they converse with other humans, we need to acknowledge that audience will be quite important for that. So obviously here, for the very perception of speech, what will be quite important will be whether you're talking to a real listener in clear speech scenarios, or whether you're talking to, for instance, an imagined listener. Because we know that from studies in laboratory phrenology, we know that can have an impact on your speech perception. And many studies in sociophonetics and sociolinguistics point to imagination also as being an important factor in sort of contributing to particular speech, particular effects. And here, some studies started investigating what happens when humans perceive speech from machines, and whether the synthetically produced speech that voice AI is producing is perceived in a similar way to how human speech is perceived. And here, studies show that actually human speech is still better perceived. But there is something interesting going on in terms of expectations. So, for instance, there was an experiment in California where colleagues were asking their participants to work with samples of synthetically produced speech and naturally occurring speech. And they were interested also in giving their participants images of either a device or a human speaker, and they told the participant that what they saw or who they saw was the speaker. And regardless of whether the speech was actually synthetically produced or naturally produced, the study showed that intelligibility of speech decreased when humans were told that the speech was generated by a device. So that sort of suggests that there may be some different expectations as to how, and different, what is often referred to in the literature as mental models that we may be sort of employing when we're interacting with machines, and that can have an impact on speech perception in these contexts. But obviously, this is an emerging body of research, so it's quite important to note that we have observed some diversity in terms of these expectations, and that these depend on context, uses, and routines of interacting with machines. And also, the very mental models may be shaped through the character of interaction with machines, experience with technology, and all this additional information that we we get about technologies as well. And obviously, individual variation in understanding how this behavior towards machine works, it differs among humans. And the obvious example, obviously, is the generational sort of differences in how people approach it. But from linguistics, we know that perception is just one part of the thing, of the speech chain that you have to be thinking about if you want to understand what else may be going on. And with humans, we know that humans develop very sophisticated, what we call in linguistics, linguistic repertoires. So these may be full of speech variation, but the speech variation is really multivariate and depends on real-time communicative pressures on the speaker. So it may be related to the audience and the type of audience that you're conversing with, but it may also be related to such factors as I don't know, the topic of the interaction, or the practices that a group is involved in, social networks. It may be also related to the social situation, the setting, many things really. And we have been observed to be very adaptive in our speech behavior. And it's therefore not necessarily surprising that when we talk to voice AIs, we also have been observed to be making some adjustments. And for instance, we have been, research corroborates that humans tend to speak louder or slower when they talk to voice AIs, or they may be hyper-articulating certain sounds. So for instance, they may be providing more extreme variants of vowel articulations and so on. And this may affect the course of interaction with machines, and also our experience in terms of the incompetence of machines, which on its own has been observed to be flexible and to depend on the nature and amount of misunderstandings made by a machine. So what we're seeing is really a very dynamic sort of communicative environment where communication may change in different ways across contexts and systems. But what is important also in the context of voice-enabling technologies is that we're seeing from this emerging body of research that these interactions may be mediated through properties of these voices. So the voices that we're interacting with do not operate in a vacuum, and we associate them also with other characteristics of speakers. And for instance, studies that, and that can, as studies shown, that can affect both perception of the speech event and also the incompetence of machines, for instance, or our vocal alignments, so what we're going to be doing when we're talking to machines. And here are some examples from these projects. For instance, it has been noted that male voice assistants were perceived as more competent than female voice assistants in a project in 2020. So gender of the that we associate with the voice may also mediate the very experience of the interaction, as studies suggest. It may also have to do with other characteristics that we associate with studies, and that can also influence our vocal alignments. And there is some wonderful work coming from, again, California, where a lot of this research is coming from, where speakers from different age groups were compared, and their vocal alignments towards Siri and human voices were studied. And this project, for instance, suggested that the largest alignment towards voices was shown in cases when the voices sounded alike in age to the participants. So we tend to sort of align with people who are similar to us in age, for instance, as this project suggests. Obviously, this is an ongoing area of research, but these sort of factors enables us to see what we have to attend to in order to fully understand when the tools may be underperforming, or what might be going on when we're working on making them more accurate as well. What all of this research also shows is that vocal alignment towards voice AIs has been sort of so far it has been argued, so that's based on the evidence that we have, that vocal alignment towards devices is pro-social, which means that spoken interactions with voice AI may influence human speech patterns in socially meaningful ways, but also that users' characteristics may shape their attitudes in ways to accommodate to the machines. And this is not extremely surprising for anyone who's coming from linguistics, because in linguistics, we would always remember that human language is really multifunctional. So it is indeed about conveying information, and referential function is there. But we do many more things with language as well. And we also do many social things with language. Often these functions have to do with the so-called socio-indexical properties of language, and especially of speech. So here, what we're seeing is that all of these functions will be activated in our conversations with computers and with machines, and therefore we need to start thinking, what do we know about the ways in which these technologies handle variation, for instance, and how they respond to different types of speakers. So in order to answer this question, we need to remind ourselves of the fact that these tools recognize and replicate language patterns based on the training data. So the training data will be quite important here. And that brings us obviously to questions of linguistic bias. And bias has been mentioned in this series before, but it has also been given a lot of attention in computational linguistics and other fields. And we know that the bias had various sort of classifications of these biases exist, and different sources of bias have been examined. And obviously, my sort of preoccupation will be mostly with data and selection, and to a lesser extent with annotation. So I want to start this part of the section by asserting that obviously most data sets will have some sort of bias built in them. And in many cases, it may be benign, so it may be really negligible, and we may not want to sort of interpret too much in some of the cases. However, in case of linguistic bias that we're seeing in the case of the introduction of voice-enabling technologies and language processing technologies, we need to be very attentive to questions of bias that may negatively affect certain groups and may put others in a very advantageous position. And that has to do also with the very linguistic data that these models are trained on and what they are able to process as well. So here I'm going to be focusing on these two types of biases. So here I'm following Blodgett, who in 2021 introduced this sort of classification into biases as allocational biases and representational biases. So allocational biases will have to do with allocation, obviously, of goods, opportunities, and jobs based on the language as well that is used in the data sets. And then the representational bias will obviously have to do with various forms of stereotyping or various issues of erasure of certain ways of speaking from the models, and issues that come from issues that we need to consider. And obviously, when we're taking a linguistic perspective on AI technologies, AI-powered speech recognition and language processing technologies more broadly, we immediately probably think about the uneven linguistic landscape that these technologies have entered. And this is what the wider context is also quite uneven. But what we're seeing is that here we have to really take into account the type of language content that these tools can be trained on, and that some languages will be better served in this context than others. And obviously, English is seen as one of the most well-resourced languages, with 60% of all content, according to some colleagues at Berkeley from 2022, coming from English. And here, obviously, the issues to consider have to do with the scale of linguistic diversity in the world, because obviously languages are very difficult to count. They're not like objects or species. There is a famous saying in linguistics which stems from already 1930s, which is that a language is a dialect with an army and a navy. So we have to remember that we're operating within definitions that we also have to critically examine. But the scale of linguistic diversity enables us to say that we have approximately 7,000 languages in the world. So the vast majority of them will have exceptionally limited resources in the digital space, and therefore the issues that people may be sort of encountering in these situations may be very different from what is happening with well-resourced languages and tools that serve those speakers. The other point that is quite important to make, and that scholars started making more explicitly, is that we need to, especially when we're thinking about voice AI, we need to be thinking about the speech samples that are used in the context of standardized speech patterns and non-standard speech. Here, colleagues at Cambridge reviewed the performance of the major ASR and machine translation tools that are offered by, for instance, Google or Meta, OpenAI, and others. And they looked at standard and non-standard dialectal language data from 7 languages from different language families. So they looked at English, but also Swahili, Mandarin, Malay, Portuguese, and Finnish, I think. They have shown that these tools underperform for non-standard dialects in all of these languages. They also acknowledge that variation, we need to also pay attention to the fact that variation, especially within human speech, is rarely addressed in mainstream tools. So this close examination of data sets is very much important to understand how perhaps some patterns of speech may be recognized more, and how that may be linked to questions of power and power inequities that we know of. So here, from a linguistic point of view, that's always an important point, because we know that there is nothing better linguistically in standard language. We may often have these societal perceptions that standard language is more accurate or sounds better, but from a linguistic point of view, all language varieties are equal, because all of them are capable of expression. So these judgments are coming from somewhere else and often have to do with questions of power. And therefore, many who are very vocal in computational linguistics, who are coming from linguistics background, have been advocating for a close examination of the construction of data sets that are used for voice enabling technologies and other language processing technologies. And here, Emily Bender, who has been mentioned in this series quite a few times, has been one of the key voices who even coined the Bender rule, that whenever you're talking about these data sets, you have to be naming the language that you're speaking about. Obviously, she was asking, she's sort of urged everybody to be asking questions about a close examination of the process of data construction as well, and whether there is consent, whether who is represented in particular data sets, but also what are the situations in which the transcripts are written, or how the data are collected. And obviously, that brings me to this point, and that I want to make when we think about the possible sort of issues that emerge with the introduction of these technologies in wider society, is that obviously there won't be one-fits-all sort of approach that will fix all of these problems, and there will be issues that will be emerging for speakers, especially speakers of non-standard dialects of under-resourced languages, may be difficult to imagine even for speakers of well-resourced languages. So these sort of have to be understood in relation to particular scenarios. And we know that, for instance, studies of marginalized languages, so these under-resourced languages that have small data sets in which they are built, these speakers may face lower performance at the hands of large language models, but it may also be the case that there may be a different type of data available, and here we need to be asking more questions about the amount, quality, and type of data, especially in the context of this variation in language, where particular types of speech performances, in our case, or other language documents that we have available for certain under-resourced languages, may just not contain dialectal variation, but it doesn't mean that it doesn't exist. Variation is not only a feature of English, but many other languages too. It may be just that it's not represented in the digital space. And obviously, these issues are so the issues that may be emerging may be traced differently depending on what we know about the construction of ASR, for instance, and what sort of data sets have been used to train these tools. And if we look at well-resourced languages, we can see that we know quite a bit about why these tools may be, as reports suggest, performing better, for instance, even when we compare mainstream varieties of English to perform best for mainstream American speakers and also Canadian speakers, but maybe less so for British speakers or mainstream Australian speakers. And this is only about the mainstream sort of speakers. So here we tracing how these tools were constructed from the beginning helps us understand why this may be the case, because we know that many of these products were trained on the various publicly available corpora, so these language data sets with transcripts that were made by humans for particular sort of speech types that were used in different, usually small sort of databases that were used. Today, we see that the major tech companies are operating at a scale that is very impressive and obviously very sort of much contributing to advances in the accuracy of these tools. Because they're talking about thousands, and here we're talking about hundreds of thousands of hours of recording. So I showed you on the previous slide that we had like 1,000 hours of recordings in LibriSpeech or 240 hours in Switchboard. So these were very much smaller data sets that were used. And now we see this push towards publicly available recordings. But there is it's not always transparent what comes into the data sets that tech companies are using. For instance, we know that Meta has revealed that they are working with 436,000 hours of recordings that include speech from different sources, including parliamentary proceedings. And here they say that it's around 400,000 hours of such proceedings that are publicly available as well, and that they sort of support 128 different languages. OpenAI talks about 680,000 hours, so it's huge. And here we have also limited information about what speech samples are come into these data sets. Google talks about millions of hours, and the largest number I have found comes from Assembly AI that talks about 12.5 million, and it claims to be 93% accurate in ASR. But obviously, when we think about the data sets, we learn that these are just multilingual training data, and we may not know enough to assess what's in these tools. So assessing what is in the tools may be quite beneficial to understand how to make further improvements, especially in the light of research that is looking at the performance of existing tools on various groups in society. And here, obviously, a lot of this research has had to do with marginalized dialects of various languages, including English, as this project at Cambridge that I described to you was doing, where it was observed, for instance, that linguistic proximity to the standard may be a good predictor for performance of the tools. So if you have a sort of a variety of English that is closer in terms of the lexicon or phonetic similarity to the standard, then the tools may be performing better. And obviously we know that for the situation is not. It is also true that higher word error rates have been observed not only in the context of marginalized varieties of English, but also for L2 speakers of English. So here studies report up to twice as high level of twice as high word error rate for L2 speakers. Obviously, these always have to be understood in terms of numbers of speakers. For English, we have, the estimates are that there are 1.5 billion people speaking English, 2/3 of whom speak English as a second language. So some of these statistics may be quite important to take into account. It may be also important to note that the tools have been reported to be underperforming in the context of multilingual speech, which may be full of code switching and language mixing, which is perfectly fine for the users of these languages, and often very important, for instance, from the developmental perspective when kids are acquiring languages in a multilingual context, or for instance, for like to express positioning in the world that people may be code switching a lot. And yet the tools have been observed, despite this push towards multilingual models, to be underperforming, and perhaps that may even force, as it has been argued in this paper that I'm citing here from 2022, that some speakers may be sort of abandoning technology, or they may be forced to adapt their language to more standardized performances. And that also may be important in the light of the fact that if we think about the global population, where like humans are at least multidialectal, if not multilingual. So some of these things have also been explored in terms of their contribution to potential existing disparities in society. And we see the NLP community addressing some of these disparities and sort of thinking what may be going on. One of the projects that started many of these debates comes from Stanford, where colleagues run thousands of audio snippets of speech produced by white and Black Americans through the major speech-to-text services that were offered by Amazon, Apple, Google, IBM, and Microsoft. And they noted back in 2020 that the word error rate was almost twice as high for Black Americans as it was for white Americans. But obviously, they had to zoom in further because, you know, not everybody who's Black speaks the same way. So here we need to also note that they noted that the word error rate was higher for Black men and the highest for those who were using features typical of African American English. And African American English is this non-standard register of English that we know the most about. It's the most studied in linguistics, and there are corpora on which ASR was apparently trained for this variety. So we see that questions that emerge from the very linguistic bias in the data sets may really sort of have consequences for what people will be experiencing with these technologies. And a lot of discussion has been sort of pushing us to think how to improve the situation, and many in the NLP community have been pointing out what the best ways to sort of improve the data sets could be. Many have argued that we need to be creating data sets that are more balanced for language varieties, and that we need to be more transparent into about what comes into the construction of the data sets. Also, obviously, these discussions have taken into account the different measures that can be used for overfitting or imbalanced data to correct for demographic bias in the data. Different ways to monitor the data set's life cycle have been investigated. And obviously, there is this push towards collecting more data and more high quality data, which may be helping us to understand and account for exclusion and misrepresentations. But as with humans, these issues that are emerging are not only obviously operating in relation to data sets as language data sets for tech development, but language can be also sort of perceived differently by different communities, and therefore there may be questions emerging that have to do with other factors in language here. So for instance, some projects that were done, especially in various indigenous communities, for instance, in the context of Maori communities in New Zealand, were showing us that the discussions may be around the willingness to contribute data, and how that also speaks to questions of intellectual property. And that also is often linked to the fact that for many, language is data, but language is also many other things. And it may be this culturally specific and very sensitive knowledge that people have, and perhaps not everybody will have access to certain types of data and certain practices, and that may also mean that these questions of linguistic representation will be quite complex, like with any questions of representation, and where some communities may not find it desirable to share their data with the AI developers. And here it has been argued that it may have to do with perceived unjust surveillance or control. And that's quite important if you think about in the larger sort of scheme of things. So if we think about the global perspective, and we think about many of the languages that are often described as endangered languages, so those languages whose speakers are dying out, and often these are smaller languages in terms of speakers, and we're talking here about estimates of between 40% of all human languages to the largest statistics I've ever read was 90%. So this is in any case a huge number of languages that are at the risk of dying out. And we're dealing with smaller communities who often might have also experienced questions of language shaming, linguistic discrimination, and oppression of various sorts for decades or centuries. So here the very sensitive debates are taking place that surround questions of privacy and maybe showing that opacity may be more important to be discussed in these cases as well. So the latest sort of discussion, this is coming from a project that was done at Berkeley, where colleagues were reviewing and sort of also proposing some recommendations for best practice in NLP development. And they were also not only pointing to the data, but also to thinking about the context of data sets and NLP systems development, were perhaps including speakers of those diverse languages in ways that could ensure that the tools serve diverse users is also quite important. Here often the discussions have also centered around setting performance goals that would advance linguistic justice debates, and also help us examine and maybe alter these power structures that the tools sort of entered into as well, if we think about it in a larger context. So obviously this talk hopefully has shown you that with great predictive power comes great responsibility. And there will be multiple ethical dilemmas that may be emerging just because we're working with language data, and that is usually the case for anyone who works with language data. And I want to end this talk by pointing out what I think I have tried to do from the beginning of the talk, is that I have tried to put your to draw your attention to the human input in the design, use and development of these tools, and also in this larger context how humans may be reacting to these sort of developments in the introduction of language processing technologies more broadly. And here I want to quote an article that was written by Webb Keane, who's a linguistic anthropologist at U Michigan, and he wrote this with Scott Shapiro, but he also wrote this wonderful book, Animals, Gods, Robots, Adventures in Moral Imagination, in which he was exploring various ethical dilemmas that may be emerging from introduction of these technologies. And in this article, he together with Scott Shapiro, reminded us that perhaps humans are morally accountable for their actions, and some of the ethical dilemmas that may be emerging in these scenarios may be very agonizing, but perhaps we always have to remember that about this human input. And here in the article, they compared it, AI hype that we have been reading about a lot, to religion, because Webb Keane is also a scholar of religion. And they concluded the article by saying that behind the hype, self-learning programs depend on human input, and even traditional diviners didn't take the signs at face value, but they interpreted them, and their answers had input from human beings, even if disguised. So when AI scrapes the web, it reflects back to us what we have put there. And obviously that may entail many ethical dilemmas and difficult decisions as well. So thank you. That's all I have. We have half an hour for questions. So happy to unpack some of the points or tell you a little bit more about the studies that I cited, or have any questions. We also have online. You do? Mm-hmm. So yes. We have a mic.
Okay, so in general with LLMs, they tend to compare it to, I don't know, 3-year-olds or 4-year-olds. When we look at these language tools they're talking about in terms of capability of learning a language, they seem to be not comparable. A 3-year-old child doesn't need 380,000 hours of speech to learn a language. So Would you say that LLMs are actually slowing us down and not just a hype, but actually preventing us from building a machine that could just interact with people and learn the language like a child does?
Whether they're slowing us down, I think it's a complex question, I guess, because it depends what you're like. Yes, they definitely perform differently to humans from my perspective, but obviously perhaps the question would be better answered by a developer who would be able to tell you more about the performance of the tools from a computer science perspective. My way of thinking about it is that they may be still handy for some speakers, and they may be, as I said before, enhancing some language users' experience in some ways as well, if you think about it in the context of some of these tools. Having a transcript may be actually quite a good idea, and also can be quite helpful for instance, solving, I don't know, societal issues that may be emerging, and the tools themselves may be perhaps what we have at the moment that enables us to enhance some of the capabilities, and whether there are others who can build better tools. That's not for me to answer, I think. So that would be my answer to that.
Thanks for the talk. Are you aware of any research, or do you have an opinion on the issues that might arise if these language recognition systems that are very centralized, right? There's like a handful of like very good LLM systems out there right now, so it's very centralized. If they are being deployed everywhere and they have certain biases against people with certain languages, have you thought about kind of the systemic implications?
Oh yeah, so there is research that is looking into these into application of these tools in multiple contexts and for different groups of speakers. Obviously, there is this emerging body of research that is also showing us that this very dialect prejudice that may be present in some of the tools may be contributing to different decision outcomes for different groups. So for instance, there was a project that was looking at, a lot of this work is coming from the States, so it's on African American English, for instance, but there was a project that was looking at the prejudice of these tools in relation to features of character, criminality, or employability. So here, the experiments that the scholars conducted were sort of looking at overt and covert biases that may be existing in these tools. And they were very interested in these covert biases that have to do with the language itself. So some of the prompts that they were giving the models that they were experimenting on had to do with the statements and some scenarios that involve statement, for instance, from some people. And based on the language that was in the statement, the model was supposed to give some recommendations. And that, for instance, had to do with employability. And then the project sort of presented some language, some text from speakers of African American English, for instance, without mentioning the race of the person who produced the text. And what this series of experiments hinted at was that there was bias of the tools in that they started giving less desirable, sort of assigning less desirable jobs to speakers based on the language features themselves. If you think about the consequences of these decisions, I think it really depends on the context and task of the tool, because obviously in this very same study, these experiments were also conducted in relation to criminality, and the hypothetical scenario that was examined had to do with giving the models statements that were produced by those who were convicted of first-degree murder. And then the model was asked to give recommendations based on the statement for what decision would be best. And again, there was no mention of race, but there were more features of African American English in some of the samples. And for those samples, their recommendation was, in comparison to other recommendations, were more often death penalty. So some of it can be quite extreme if you think about it. So thinking about how much we know about these tools and what they may sort of bring with them in particular contexts, really, I think really requires close examination of the context of use, and also perhaps more work on working with the lived experience of different communities that may be affected by these tools as well. So that would be sort of my way of looking at it. But it's an ongoing area of research where you see also scholars sort of investigating how the tool's responses could be improved and whether they could be improved in some ways. So in this project, it was argued that, for instance, based on some human feedback that was used for training of the models, it was suggested that the models improved in terms of overt racism, but not necessarily in terms of all outcomes for covert racism. So there's still probably, this is an area that is being investigated, as far as I understand. Yeah. Behind you.
Dr. Kozminska, excellent talk, so many questions. One question I have for you is just kind of understanding the various deficits in the field that you pointed out here in terms of ASR and NLP, and projecting it into the future and thinking about ways in which we might redress some of those deficits and imbalances, right? So for example, are there ways you think that we can develop tools for communities that are wishing to develop corpora for themselves, whether it's speech or annotated bodies of text? How might they build those types of corpora for themselves, and how, thinking even deeper, how might they then position themselves in order to have any kind of monetization of those resources, the economic benefits thereof to accrue to them at a community level. And then one final question, again, thinking about the future, if we are to redress some of these imbalances and we can begin to build corpora in multiple dialects, in multiple registers of the language, for example, how might we use the LLMs of the future to train humans on implicit bias?
Okay, so quite a few questions here. So in terms of data sets that can be built by various communities, I think that we are observing such initiatives across the globe. So for instance, some of such initiatives started in various places. For instance, in Africa, if you think about the number, like linguistic diversity, then we can sort of immediately say that yes, Europe is diverse, but it's not as diverse as Africa, Asia, or the Pacific. So there is a lot of linguistic diversity in Africa, and many of the languages that are spoken are not well served by LLMs and by NLP more broadly. So there are some bottom-up initiatives being sort of implemented by speakers of those languages who sort of work with the data sets, who construct data sets for those languages, and successively they have done that with some success. We know that some of these initiatives can be extremely successful, and here I'm thinking about this sort of, it's not necessarily LLMs, but like technology, an introduction of technology in some contexts where these language relations are very uneven. And here I'm thinking about MIT's initiative for technology in education in Haiti. So in Haiti, for instance, this is like a typical scenario of some of the post-colonial contexts where you may be dealing with what is often referred to in linguistics as a diagnostic situation. So you have 96% of the population speaking Haitian Creole, and yet French is being used in education. So one of the Creolists from MIT has been involved in this initiative to also create resources and technologies with the local population in Haiti to promote STEM education in Creole. And it's often argued that some of these initiatives are very important for educational purposes, for instance, because people may be performing better if they receive educational in their L1 and things like that. So we do know of some successful sort of initiatives that are coming from a combination of sort of initiatives, so either bottom up or also sort of initiatives that combine efforts from local populations with technologists coming from different parts of the world. Linguists are maybe involved, as you can see, in order to sort of make up for some of the make up for the lack of these technologies in some contexts. And then your question about the future, the second one was about, I'm sorry, enough.
New words, the economic benefits.
The economic
benefits. For example, licensing these types of tools to big companies.
Yeah, so so it is also sort of suggested as a way forward for many communities who may be disadvantaged. For instance, the World Economic Forum has been sort of discussing opportunities that arise from the introduction of these technologies for populations who otherwise may not necessarily be making some economic gain, having some economic gain. And it has been argued that it may be also quite important for sort of access to resources in these communities and obviously access to your jobs and other things. So definitely the discussion is suggesting that people are seeing that also as a possibility for economic development as well. So the discussion is really quite complex in how to secure that these biases are perhaps more attended to, but also how we make sure that the technologies may create new opportunities for communities. And the final question was, I'm sorry, I'm very bad.
LLMs in the future for podiatry.
Okay, so yes, so LLMs for training humans. I think we would first have to train LLMs so that they meet some sort of a threshold that is enough from the human perspective, and obviously we could argue that then humans could benefit from that, from LLMs meeting that threshold, and also from interactions with them. But I think it's a lot of work to do to reach that threshold in some scenarios, and definitely is related to understanding the consequences and fairness in action, rather than only, you know, sort of looking at fragments of how fairness in these cases work. And I'm afraid we're going to be learning how this works as we see further developments. I'm sorry, this is a very lengthy answer. Do we have any other questions?
Thank you. So I would like to know, from your perspective as a researcher and lecturer, what impacts do you think AI could have in the development of children and teenagers in their creativity and authenticity in speech and text composition?
Text composition, okay. I think from so obviously we can see that these tools may be helpful for situations where you're dealing with, I don't know, speech disorders, or when you're dealing with situations where perhaps the tools may sort of offer new ways of understanding how to compose text, or how to sort of engage in different speaking styles, as just by offering new ways of interacting for younger generations. Whether I'm able to assess the future and what it's going to look like, I think that may be, of course, beneficial, but I think I'm still limited with my answers tonight. Sorry. So sorry. That's a good question, though. Yeah, thank you. Do we have any other questions? Yes.
I was wondering about the what way the change from systems built more on linguistic and phonetic knowledge to more data-driven and unsupervised systems, how that relates to the type of biases and power imbalances that are caused. So, like, could it be that using maybe more data-driven approaches on corpora, like, for example, YouTube, that might contain a very diverse range of accents, could have some positive effects compared to guess what I'm especially interested in is the systems that rely on feature vectors of phonetic features. Do you think those phonetic features, like, first of all, are they things like place and manner of articulation, or are they more acoustic than that? And do you think that those features are sort of universal enough that they are less, that they exhibit less of those bias issues?
Okay, so definitely the incorporation of large data sets enables opportunities for dialectal speakers as well. So if you think about the YouTube, as you mentioned, it is full of, I don't know, for instance, multicultural London English, which is sort of used by various speakers and perhaps with traditional methods wouldn't necessarily feature in some of the training data sets. So obviously the tools have the capacity to sort of adjust to non-standard performances, and very much by sort of building on phonetic features that sort of enable them to understand relevant contrasts and also understand contrasts between words that have to do with different pronunciation patterns, and therefore that may sort of create more chances for some of the tools to learn how to deal with this type of data. It's a little bit less known what type of data is in many of these tools and how much of it is sort of representing particular speakers. So I think because of that, you see this turn for transparency, for sort of like understanding what sort of performances we're dealing with, to understand to what extent the tools can actually learn more about different dialects based on the phonetic features that they are exposed to and sort of learn from as well. So obviously we're seeing that that there is a better performance because of this inclusion of the larger data sets as well. So that's definitely there. I think the talk has been sort of obviously sort of also focusing on these biases, because there's been a lot of attention given to biases in this literature to understand what opportunities, but also what risks sort of stem from introduction of these tools. And obviously that may mean that there may be quite a few opportunities for dialect speakers too, just because of the data sets and how the tools are learning how to deal with them. Okay. Have any? Oh. Do we have any questions online? We don't. So.
I think you know.
Well, we had in the chat, but we.
I don't think the chat works. There's like a Q&A.
Oh, this one. Okay. Wonderful. Okay, what are your thoughts on sentiment analysis through ASR, given how important context of language use and speech is? So obviously, I think it could be quite an interesting avenue to explore in terms of yes, so definitely ASR could be quite beneficial for sentiment analysis if we want to understand how sentiment sort of analysis works. We know that a lot of it has been done on textual language data, and obviously that has often been an area that is related to semantics, and we know that quite huge advancements on this front have been made. But if ASR is incorporating to some of these, to this type of analysis, it could be beneficial, because obviously speech brings yet another layer of information that is key for understanding sentiment and understanding, for instance, the intentions or the variations in I don't know, in tone, or variations in the intonational sort of contours that you may be observing in the data, may be useful for a better recognition of these sentiments as well for different speakers. Obviously, that comes with larger data sets, and also understanding how that works for different speakers. So you also know that speech is full of variation in terms of how we express sentiment and how we express emotions. So here, having this understanding of the variety is also something that could be explored simultaneously to not to sort of make sure that we account for variation. But definitely, I would argue that that's quite an interesting way forward. I'm sorry. Okay, so we don't have any more questions online, no more questions in the classroom. So I think we can call it a day tonight. And we have one more talk in the series, which will be on the 3rd of December. So on Tuesday, and there will be a reception on Tuesday. And Felix is going to conclude the series. So thank you very much for coming.